Hello, my name is Timothy Cheka, and today I'll be presenting my findings on how different weather phenomena affect the heights of skyscrapers around the United States. Skyscrapers are large buildings that are predominantly built in urban environments. The reason to build skyscrapers are to create more room without taking up too much space. Different weather phenomena might affect how tall skyscrapers can get. Earthquakes shake the ground, wind blows harder at higher elevations, and hurricanes topple buildings over with intense storms, all of which could create hazards that prevent buildings from getting too high. I want to know how each of these natural occurrences affect the heights of different buildings. The first thing that I did was I broke down the raw data into an abstraction. An abstraction is a simplified representation of a real-world entity. I broke down the skyscraper's dataset and created quantitative measures and visualizations with the help of three properties. City is a string property that lets me know where the building was built. Height is a float property and tells me how tall the building is. Year is an int property and tells me when the skyscraper was built. Before I reveal my results, I need to explain some of the limitations that I faced on this project. There was data missing from the dataset that might have been helpful when doing this project. Data like what state these buildings were built in. This dataset did not give information about different states, only the cities. It would be nice to compare the skyscrapers on a state-by-state basis instead of a city-by-city. Another limitation would be value. It would have been nice to evaluate the cost of building skyscrapers in one city compared to another. The final limitation was time of year. Especially for looking up hurricanes that only happen in the summer, it would be nice to filter out the non-hurricane season skyscrapers to see if that data turned out any differently. This slide shows the structure for the dataset that I used. It starts from a list and goes into a dictionary. For skyscrapers, we are interested in looking at the city key under the location dictionary, year, which is under the status dictionary, and height, which is under the statistics dictionary. The first question is about earthquakes. California sits on the major San Andreas fault line, putting the most populous state in danger. According to a recent World Geological Survey, California is more than 99% likely to be hit by a big earthquake within the next 30 years. Both Los Angeles and San Francisco are two of the largest cities affected by this. Based on this, some construction companies might not want to build larger buildings in that area. What is the distribution of heights of skyscrapers in these cities? Based on the histogram created, most of the heights of the skyscrapers in the major earthquake zone of California are between 75 and 150 meters. Most of the heights, however, lie in the 100 to 125 meter zone, at just above 40 occurrences. Question 2 is about wind. Wind is a huge factor in how tall a building is built. The high winds could topple a building over in seconds. According to the Weather Channel, Boston, Oklahoma City, and Buffalo are 3 of the top 10 windiest cities in America. On the other hand, Phoenix and San Diego are 2 of the least windy cities. Is there a difference of how tall the skyscrapers get in windy cities and non-windy cities? The bar chart on the left shows each city individually. From this graph, we see that the windy cities have the tallest structures located in Oklahoma City and the shortest structures located in Buffalo of the data. The bar chart on the right shows the average of the high wind areas and low wind areas. From that chart, we can see that there is a very small gap between the average heights of the skyscrapers. Hurricanes are a third weather-related occurrence to affect the building of skyscrapers. Florida is one of the states most affected by hurricanes, as it sits directly on the Atlantic Ocean and the Gulf of Mexico. Because of this, cities like Miami and Tampa Bay are always in constant hurricane watch. Over time, the heights of skyscrapers could decrease because of the threat of impending hurricanes. Is there a correlation between the height of a skyscraper in these cities and the year that they were built? The scatter plot above shows the correlation of heights of buildings and the years that they were built. From the scatter plot, it can be seen that there is no correlation between how tall skyscrapers are and when they were built. The social impacts of this project include the following stakeholders and conflicts. The stakeholders include owners, insurance agencies, code officials, and construction companies. Owners want to make their buildings as tall as possible to get as much money as they can from them. However, if the skyscrapers get destroyed by natural forces, they could stand to lose money. The taller a building is, the greater room for profit, but the greater risk of failure. Insurance agencies could increase premiums for skyscrapers in areas that have higher risk of collapse due to natural phenomenon. In this case, they would want the buildings to be taller in order to make more money. The code officials are in charge of making the rules for tall buildings. In high wind areas, more bracing, for example, is needed. The taller the building, the more codes have to be enforced in order for the building to be considered safe. The taller the building, the more unsafe it is to build. When the building is being built in an area that is at risk of collapse, it increases the safety needed on a construction site. This might increase the cost to build the building due to increased safety measures and not having enough people to do the work. Potential conflicts between these stakeholders include owner versus construction companies versus code officials, and insurance companies versus owners. Owners want to get the building done for the cheapest price possible. The construction company wants to make as much money as possible. This is a natural conflict between the two stakeholders that arises at every construction job. Construction companies must follow all code guidelines that are given to them by the code officials. Not all companies do this, though, because it either costs too much or takes too much time to do. The results are fines and sometimes lawsuits given by the code officials. If insurance premiums increase too much, then it might become too costly to build skyscrapers in that part of the country. Instead, owners might look elsewhere to build their buildings at a cheaper price. That is the end of my presentation. Thank you for watching, and I hope you have learned something about how different weather phenomena affect the heights of skyscrapers across the US.